concentration area to a low concentration area. Now, a variation of this is facilitated diffusion. Facilitated diffusion is still diffusion you're doing from a high concentration area to a low concentration area. But this time it involves carrier molecules, carrier proteins. An example I like to use is floating down the river. So if you're just floating down the river, you're going, well, the river current is carrying you. All you have to do is not drown. The river is carrying you along. Facilitated diffusion will be floating down the river in an inner tube. So the inner tube is carrying you, but you're still floating down the river.
You're still going from high to low concentration?
Yes.
Okay.
Yes, you're still going from high to low concentration because it's still diffusion. The only difference is you've got a carrier molecule, but the river's still carrying it. So anyhow, diffusion you're familiar with. Facilitated diffusion is simply a variation of that. But osmosis, definitely more tricky. Definitely more tricky. We won't finish it tonight. Osmosis is the diffusion of water through a semi-permeable membrane. Semi-permeable means some things will pass through, some things do not pass through. It's usually based on size. It's like pouring things through a sieve of some sort. So the smaller the holes, the more everything gets stuck. That's kind of what the cell membrane is like. So a semi-permeable membrane, some things get through, some things do not. It's like a brick wall. That would be impermeable. Nothing gets through. But semi-permeable, some things get through, like water. And the example of a semi-permeable membrane is the cell membrane. So we all have it. So we're going to have a beaker with a semi-permeable membrane. And over here,
can you turn the light on there?
I'm sorry, what?
Can you turn the light on there?
I can't hear you.
Can you turn the light on behind you so I can see?
Oh,
Thank you. Better.
5% glucose, and here 10% glucose. With that membrane in between. The dotted line is the membrane. You have a 5% glucose solution, 10% glucose solution. Actually, I'm pretty sure I need to explain what that is. Percent concentration is probably the second most common method of describing concentration. It's something you will run into a whole bunch. Not so much for me, but with your careers, your jobs, because medically they use this a lot. So percent concentration is the grams of solute in 100 milliliters. 100 mils for 100 milliliters of solution. So in this case, our solution is glucose. We have glucose dissolved in solution. The solute is what is dissolved. So again, in this case, it would be glucose. But for example, salt water. Salt water. So salt water, solute would be salt. The grams per solute, or the grams of solute per 100 mils. See this, that's your percentage. You know, percent is per 100. So in this case, 5% glucose means 5 grams of glucose in 100 mils of solution. That's your 5%. 10% would be 10 grams. But it doesn't have to be 5 over 100. That's your definition. But for example, it could be 50 grams per 1,000 mils. See, that's the same percentage. Or it could be 0.5 grams in 10 mils. So you can make whatever volume you need, but the percentage should not change. So that's percent concentration. Again, medically, you're going to see that a whole bunch. I mentioned it's probably the second most common form of concentration. It's not exactly like I made a study of it, but I would say molarity is probably more common, like a 3 molar solution, 5 molar solution. But for you guys, you will see percent concentration almost forever. And I am out of time for tonight, so any last question before we quit? Okay, I'll remind you, quiz on Monday, quiz on Tuesday. Anything we've talked about is fair game.
Oh no, that's all nice.
How many questions is it?